judge that evolution is valid with the best evidence possible. Therefore, in your case of judge, which line of evidence for evolution would you be sure to include in your case of judge? Which line of evidence is most dispensable?
I think the strongest piece of evidence is molecular homology because when they did an experiment between who they took a fragment of DNA from humans and one from a chimpanzee, they showed that 97.6% like shared DNA sequence. So that's why. And it shows like inherent, like that we it shows like evolution because it shows that we have a common ancestor within other species.
For me, I think the strongest one was actually anatomical homologies because I thought it was really interesting how different animals can have different forelimbs and stuff, but they have the same inner structure. So they would have the same humerus, they would have radius and an ulna, they would have carpals and metacarpals, everything the same, even though, like, say with the bird, if evolution didn't exist, there would be other ways to make better wings other than in this sort of outline. But since I think it proves evolution because it's actually in this pattern and not something else.
I think that I see what you're saying about the DNA or the homology molecules, but I think that the most important one would be fossils, since like in the book in Your Inner Fish, like they talk about the tiktaalik and how it's a transition fossil. So I think that's very important because like with homology molecules, you're only able to look at recent like animals like chimpanzees and things like that, since DNA is not able to be preserved for a long time. But if you look at fossils, it shows from like 3.5 billion years ago and like things like that. So it shows over a long time scale, and that's something that's very key to show to the judge that it hasn't just been happening recently, because you can only provide that with DNA. But with fossils, you're able to show it as a big time scale and how it has come over time.
I agree with Janet. Because fossils, it lasts more time and DNA doesn't. So, yeah.
I also agree with Janet about how like tiktaalik was like the animal like transitioning from like water to land living, and like that also like shows like ultimately we became like bipedal and like had like limbs and like be able to like walk and stuff. That's why I agree with Alan, we should talk about anatomic homologies about how like we like share like similar bone structures with other animals because we had a common transition.
I think the most effective way to figuring out like whether evolution existed or not is by DNA or RNA. I understand what everybody's saying, but I want to agree with Daniel's statement because paternity tests are determined by DNA or RNA. I thought about that, like somebody can't find their parent or whatever, they take blood tests or anything like that. And like Jamila said, they compared human DNA with chimpanzees, and they found that 97%, similarity between humans and chimpanzees. So I think that would be key to figuring out whether we do have common ancestors or not.
I agree with both, well, Arnia and Janet, because I see that how with DNA, I see it as it's important in the fact that it can show who humans are most likely like evolved from, and fossils can show how the animals evolved like after like millions of years ago, and how like they changed and how fish became like land living animals and stuff. So like, I see that both are important, but I also agree with finding most that DNA is the most important because with DNA you can also track how in a way you can also track the anatomical way, because like with the DNA you can see who you were related to, and you can see who those animals were related tell like, oh, this would relate to this, so would kind of also look like the ancestor of our ancestor.
I agree with Jackie and what she just said about our ancestors and our bone structure because of the Cali, like they do fishes like we do, so they kind of have like the same bone structure like right here. And then also human, cat, whale, and bat, like they have 4 limbs, and then basically that shows a sign that we evolved from the same ancestor. And yeah.
I agree with all you guys. I think the most important evidence of evolution would be anatomical homology, because like in the book it showed how like us humans have like the same arm structure as like the seals and like the penguins and the lizards.
I say to expand on that, I also I read in the article on anatomical homology about how some birds like chickens and ostriches, they have claws, and no other bird has that. And they have a common ancestor, which was long ago in like the prehistoric era, which had claws, and they still use them now, so they're not like the vestigial organs and stuff that aren't being used, but that I think that makes a stronger case for anthropoid homology.
I also believe that DNA is a good source of evidence for evolution because, like, I mean, every organism has DNA. Like, I mean, even though like not related, some of them, but like they have like some can be mutated, some can have different strands of like pairs, but like our DNA has been passed.
We've all touched on the importance, but like, what would you leave out? What would you guys think is the least important, and why would you present?
For me, I'd say biogeography, because I mean, I know it's important because it shows that even when all the continents were together, you know, they migrated to different parts, so they share a common ancestor. When the continents are separated, they still share similar traits, but I don't think it's as strong as anatomical homology because sure they have some traits, but because of the distance and because of the differences they have with one another, it would be hard to I guess say that they are really like common ancestors. So I'd say biogeography.
I think that biogeography is an important one since it's important to like being able to find fossils and things like that. So like if you want to look at fossils from the past, you have to look at how the continents were shaped. And also I think it's important for natural selection, the way that the animals used to adapt to change in the environment. So it'll show you like extinctions and things like that, and like where animals' ancestors left off and how they started changing, where it branched off. So I think that's kind of an important one also.
But like in natural selection, it is like in evolution it says like a new species like is created, right? So like in natural selection you have the same species, so it don't change, so it don't show any change because it's not new.
I think that has evidence.
You could just say evolution is real, but you have to have proof to back it up. And fossil evidence, fossil record actually gives you proof that how a species changed over time. Like for instance, we watched that video we had to watch. You know, the man, he showed like how horses they changed over time. Like how at first they had like sharp teeth, they had many digits, and how they evolved to have like one digit, and like kind of soft teeth.
I agree with Jasmine, because in your inner fish, I also agree that fossils should be in line, because like there's a picture here in page 31 where it shows the arms and like how other animals share like their arms, like there's a seal, there's a bird, a human, 1 bone, 2 bone, and 3 bone, and that like kind of shows how we are like closely related to like fossils and bones we share.
Okay, well, fossils, that is a good way to look, but I think that molecular homologies is the strongest line of evidence because by looking at DNA evidence, you can see how close organisms are down to like the exact similarities in the genes. Like every organism, like we all share a universal genetic code, so that's what makes it easy to compare like DNA and RNA. So by comparing similarities in the genes, you can see how close
organisms are to each other. Like, the more genes alike, the more closer the two organisms.
I agree with Celine, because DNA and RNA are from 4 base letters, and that all living things with their DNA have those letters. So I think that like they have one common ancestor, they must have this.
Going back to what you said about the animals have the same bone pattern, like Richard Owens, the 1 bone, 2 bone, and rods. I think that anatomical homologies are best evidence for evolution because they show, so animals have like the same digits and like structures, but they all like evolve differently based on their function. Like some of them might be longer and stuff, but they're all common. So then that means they must all evolve from a common ancestor because like they couldn't all just evolve independently like every single time, same thing, just different sizes.
I agree that homology or molecular homology does show evolution, but I think that the most important one would be experimentation, because without it, you really can't find that molecular and artificial selection and natural selection happen, because you need proof that that happens, and that supports evidence, and without experimentation, you can't find it.
Going back to what Dalia said about she thinks the anatomical one is the best one. I think that is a good way to look at it, but like Yane said, every organism has a common ancestor, which means their DNA molecules are all derived from one organism. And so organisms can look the same, but in actuality they can be different. So, but if organisms have similar DNA, they're guaranteed to be similar no matter how different they look. The fact that organisms can look different but have the same DNA proves that evolution occurred.
Yeah, like the other that I was saying about the bone structure, the sonic hedgehog gene, that's like a gene that helps form the limbs in every like animal limbs, and I think that's important because that gene is in like almost every animal with limbs. So it's like a gene that helps create it. So I think it shows that
How it ties together?
yeah.
Yeah. So both one are important, DNA and other structure. Because they come from the same. But DNA does leave another structure, right?
I see you guys' point, but I think that natural selection is the most conclusive evidence for evolution because Charles Darwin's theory offers it through variation of traits, the creation through reproduction, and hereditary. I'll just make that word up. Because during the Industrial Revolution, industrial melanism affected 70 species of moths, and variation shows because it was light moths and dark colored moths. And in the reproduction, light moths got eaten by birds that were visible because of the suit that darkened the trunks, and the dark moths were able to reproduce because they were being eaten, and that shows hereditary because dark moths were able to survive. And but that shows, well, it's evidence for evolution because we're able to see the population grow, and you won't see any more white moths, but you'll see more dark moths.
When they say like natural, they be like, you know how like when people say evolution, they like evolution by means of natural selection. So yeah, so natural selection is like leading up to evolution. So it's kind of an example of evolution. I wanted to tie into Pierre's point with Elena's point. The reason that you said about the moths, well, the reason that they changed and the way that you're able to look at it is if you look at the structure and the 4 letters, you can be able to tell where the change was made and how it was changed. So I think that those are like the main ones that can be tied together. Like if you look at the genetic code of the animal and how it changed and how it had to change to adapt, and then you have fossil evidence of the structure, then it comes together. So I think